Hi everyone, I'm Carl Shepherd, the Data Jiu-Jitsu guy, and today I'm going to talk to you about the Data Lakehouse. Before we get into the content, I thought it was worth giving you a quick introduction. I have over 15 years experience within the data industry. I started out as a business intelligence developer and I've worked in a variety of different data roles, and I currently work as a data architect. This video is part 4 of a 4-part series where I discuss the journey the data industry has been on over the last 20 years. If you haven't watched the other 3 parts of this series, I strongly suggest you pause the video and go back and watch these because I'll be making references to them throughout. This series is aimed at anyone with an interest in data, and I'll aim to keep it as simple as possible so that everyone can understand. Data is becoming an increasingly essential topic for everyone to understand and is no longer just for data professionals. So before we get into the content, I'd like to go through the agenda. I'm going to start by telling you what a data lake actually is. And then before I go into why you would use a data lakehouse, I thought it'd be worth doing the comparison between the modern data warehouse, which we talked about in part 3, and a data lakehouse. Then we'll go into why we would use a data lakehouse. And then we'll look at how does this actually work in reality. And then we'll finish with summary and next steps. So first of all, what is a data lakehouse? This particular description by Databricks, who are one of the main companies that champion the data lakehouse, I think is a really good one. So what they say is that a data lakehouse is a new open data management architecture that combines the flexibility, cost efficiency, and scale of data lakes with the data management and ACID transactions of data warehouses, enabling business intelligence and machine learning on all data. I think one of the key things to take from this is that what the data lakehouse aims to do, which I think the clue's kind of in the name, to be honest, but it tries to take all the best features of the data lake and the data warehouse and then combine them together into a single platform. And again, for those of you that are more visual learners, this is a data lakehouse diagram that was provided by Databricks. And what it also does is introduce you to the medallion architecture, which I'll briefly talk through now. So hopefully you all find this relatively simple, but here on the left-hand side, we've essentially got batch and streaming data. So that's essentially any type of data that your organization possesses. First of all, that will go, this raw data will go into what they call the bronze layer, and then that will move through into a silver layer, which is generally a more refined and clean version of what is in the bronze. And then finally, you've got the gold layer, and this is the part where you would do all of your business intelligence reporting and any kind of ML, which is classed as machine learning. And this gold layer in the data lakehouse basically acts as your data lake as well as your data warehouse. So just to give you a little bit of extra information on the medallion architecture, the bronze layer, as I mentioned, is essentially just like a replication of the source data. So it comes completely raw. Your silver level is essentially that central enterprise data repository where it's giving you a cleaned version of what comes in from bronze. And then finally, you've got your gold layer, which is where, if you remember from the data warehouse video, this is where we look at doing things like your star schemas. And then you'd also, within this particular area, you look at optimizing some of your data sets for machine learning so that data scientists can use that instead. If you'd like a technical deep dive on the data lakehouse, and then this paper, this academic paper, which is only, I think it's about 8 pages, which was written by Databricks as well as Stanford University and UC Berkeley. That goes into the data lakehouse in really minute detail and gives you the sort of thought process as to why they believe that the data lakehouse is the kind of the future of data. Now we're going to compare the modern data warehouse, which I talked about in part 3, with the data lakehouse. So just thought it'd be worth showing you the modern data warehouse structure again. I'm not going to go into too much detail, but if we remember, you've got your data lake and your data warehouse, and they were both used for different purposes. It was all in a single platform, but you had two areas of where you were storing data. Your data lake is where you would do your predictive and your prescriptive analytics, and then the data warehouse was where you would look at your descriptive and diagnostic analytics. So the difference with the data lakehouse is that it simplifies the overall architecture. And the way it does that is that, as I mentioned earlier, you've got your medallion architecture, so your bronze, your silver, and your gold. And then all of your analytics, your descriptive, your diagnostic, predictive, or prescriptive analytics is all done from this gold layer, which means that you've no longer copying data from your lake into your warehouse. It's all contained within a single platform. And one of the main reasons this has now been enabled is through something that they call something that Databricks created, which is called Delta Lake, which I'll talk about in a little bit more detail. So the modern data warehouse versus a data lake house. So most data professionals, including myself, always felt that there would be a need for an actual database to host a data warehouse. But now the new tooling is changing that thought process. So Delta Lake and Apache Iceberg, just two products that are enabling that. So what Delta Lake and Apache Iceberg do is they essentially allow you to convert data lake files into tables, which is what enables you to do everything, all of your BI or of your ML from that gold layer rather than having to separate it out between a warehouse and a lake. But one thing to highlight is that Delta Lake and Apache Iceberg are still not as mature as traditional databases because obviously databases have been around for a long, long time now. One of the main things with Data Lakehouse is that you no longer need to copy your data between the lake and warehouse, and your gold layer becomes your layer for all analytics. And I think an important thing to point out, which is what's pointed out in the technical deep dive document that I talked about, is that the data lakehouse doesn't speed up the time taken for modeling data into your star schema. Um, so you obviously still need to do the work that we talked about in the first video of modeling that data into a star schema, and this would happen between like your silver and gold layer within the data lakehouse. Just one thing to highlight, and it's interesting to see how this plays out, is that some data warehouse vendors are now offering serverless options. So this potentially has a part to play, and I'm very keen to see how that plays out. And another thing as well is that the medallion architecture can still be built within the modern data warehouse architecture that we talked about, where you have a separate lake and a warehouse. And I think that's kind of the approach that a lot of organizations are taking at the moment, and that will act as a bit of a halfway house between the modern data warehouse and a data lakehouse. And also, the data lakehouse is still evolving at a really rapid pace, and Databricks are one of the vendors that are leading the charge on this. And as I mentioned in the previous video, modern data warehouse is probably still the most common approach, with a two-tier of a lake and a warehouse. But I believe we are starting to reach that tipping point where organizations are starting to move more towards the lakehouse approach. So why would we use a data lakehouse? So data staleness is an issue with the modern data warehouse because the lake will always be updated before the warehouse layer. In a lot of cases, this doesn't really matter, but if you've got reports that come off the warehouse layer that need to be run quite frequently throughout the day, then there's going to be a time where your data lake and your warehouse are out of sync. Data reliability is also an issue with a modern data warehouse because if there's some ETL processes that fail between your lake and your warehouse that haven't been fixed or they've been missed, and it could be that you end up with data differences between your lake and your warehouse, which is a really big problem. What the Lakehouse also does is it provides you with a simplified architecture, and data engineers have less ELT or ETL processes to develop and maintain. What it also does is the data warehouse is it makes it easier to handle real-time and streaming use cases, which kind of ties in with the data staleness one that I talked about. Um, Certain companies will require reports to be run that require data pretty much at real time. And the data lakehouse makes this a lot easier than what it would be if you were using the modern data warehouse, which has got data in the lake and the warehouse. Another thing that it does is that it avoids commercial data warehouse data lock-in. And what we mean by that is that if you push your data from a data lake into a data warehouse, and you're using lots of reports and things off that particular data warehouse, it becomes quite difficult to move away from that particular data warehouse because you'd probably have to, copy your data from the data warehouse into another area to start using. So yeah, you don't. You can easily get locked in into a data warehouse. And finally, what I think is the most important reason to use it is the total cost of ownership is actually reduced with a lakehouse because you save money on compute and storage on the data warehouse and data engineering development time. So how does this work in reality? So I've put up our simple medallion data lakehouse architecture up here again. So firstly, a business decides to invest in a data lakehouse to help them solve all their analytical needs in a single platform and reduce the total cost of ownership. A data engineer can then work at the business to establish what data is required. A data engineer would then extract the data required and load it into the bronze area of the data lakehouse. A data engineer can then transform the data required and load it into the silver area of the data lakehouse. And then a data engineer can perform additional transformations and load the data into the gold area of the data lakehouse. As I mentioned earlier, this is where the star schema would typically be built. And then a data scientist can use the gold area of the lakehouse to perform some form of predictive or prescriptive analytics. And then also, a data analyst can also use the data lakehouse to perform some form of descriptive or diagnostic analytics. So what this highlights again is that once the data gets into your gold area, your data analyst and your data scientist can just use the exact same source of data. So I'm going to give you another real life example with the airline, which we've used throughout the series. So again, first step is the decision. So a decision can be made that the organization would like to create a data lake house, and their priority is to look at ticket sales and customer information. You've then got the development side of things. So the data engineers extract and load the appropriate data required into the lakehouse, and this goes all the way through into the gold area. Now then from here, we've kind of got a two-track approach, which we didn't have previously. So in your analytics area, you've got data analysts who can create a customer ticket sales dashboard for end users to consume. And you've also got the data scientists that can create a forecasting model to predict ticket sales for the next 12 months. So the end user of the dashboard uses daily to track performance and notice a drop in sales for flights in Spain. You can also analyze the forecast data, and you notice that you are understaffed in certain areas to keep up with the predicted demand. And then within your action, you've got two different types of actions. So from the data analyst side of things, you've got investigations into the drop in sales to Spain to try and rectify this problem. And then you've also got from the forecast information that the data scientists provide, this can be distributed to the appropriate stakeholders. So decisions can be made as to whether to recruit new staff or not. So now just to summarize, at the time of recording, as I mentioned earlier, modern data warehouses are probably still the most common way for data platforms to be built, but we are starting to reach the tipping point where the data lakehouse is becoming the main approach. We are also noticing that organizations appear to be using the medallion architecture and also keeping the two-tier approach of a lake and a warehouse. I believe personally, it's no longer a question of if the data lakehouse is the correct approach, but when is the right time for organizations to start adopting it fully. The technology supporting the data lakehouse is evolving at a rapid pace, and I'm very excited to see where this goes. Moving from the modern data warehouse to data lakehouse obviously requires time to implement. So it's likely that the two-tier approach will still be around for some time yet. This is the final video of the series on the data analytics journey, and I hope you've all enjoyed it. In my next video, I plan to do a technical deep dive into the Data Lakehouse to demonstrate how this works in a bit more detail. And finally, thank you very much for listening. If you've enjoyed this video, then please like and subscribe. And if you've got any questions or comments, then feel free to add them to the section below. Thank you very much.